Welcome to the video on discrete random variables, expected values, and applications. So a discrete random variable is a variable that can only take on integers. So it can be positive whole numbers, negative numbers, or zero. There are two different ways that you can write your probability distribution for a discrete random variable. The first way is in a table like this, where you have x, which is your variable, 1, 2, 3, 4, or 5, and then the probability of x. So there's a 0.4 chance of x being 1. So 40% of the time the answer will be 1. And so on, 5%, 10%, 20, and 25%. The other way to write your probability distribution would be as an equation shown here, where you have the probability of x equaling x is 1/15 times 3 plus x, for x is an element of 1, 2, 3. So these are the numbers you would plug in for x. So if we were to draw it as a table, you would have x being 1, 2, and 3. And then your probability of x being equal to x, you would plug each of those numbers into the equation. So you'd have 1/15 times 3 plus, and for 1, we'll just plug in a 1. So this would be 1/15 times 4, which is 4/15. So that's your probability of 1. Then for 2, you would have 1/15 times 3 plus 2, which is 5/15, which also equals 1/3. And then for 3, you have 1/15 times 3 plus 3, which is 6/15. So this is 1/3 and 6/15. And if you add those together, it'll equal 1. So your probabilities need to add up to 1 because the total has to be 100%. So this is what your second probability distribution would look like if you changed it into a table. So next we have the expected value. So the expected value is the value that is most likely to be the result of the trial. So the sum of each outcome is multiplied by its probability. So if we had x being 1, 2, and 3, and the probability of x equaling x is 4/15, 1/3, and 6/15, like on the previous slide, our expected value for this, e of x, would equal x1, which is 1, times our probability of that, which is 4/15, plus x2, which was 2, times 1/3, plus 3 times 6/15. So this is 4/15 plus 2/3 plus 18/15. So we're going to want a common denominator, so we'll change that to 15 by multiplying it by 5/5. So we have 4/15 plus 10/15 plus 18/15, which equals 32/15, which is approximately 2.13. So our expected value in that trial would be 2.13 or 32/15. So some applications of this would be gambling in a casino. You want your expected value to be positive because you want to be making money over time. The casino obviously wants your expected value to be negative because they want to be the ones making money. So if your expected value is 0, then that would represent a fair game where x is the amount of money earned by each player. So overall, people are winning as much as they're losing. Other applications would be business decisions or return on investments. So here we have our first IB practice question. It says, the probability of x equaling x is k times x for 1, 2, 3, 4, 5, and 0 otherwise. Solve for k, then find the probability that x is greater than 4. So if we drew this as a table, we'd have x, and p of x equals x. And then we have 1, 2, 3, 4, and 5. So for 1, it's going to be k times 1, so just k. For 2, it's 2 times k. 3, it's 3 times k. Then we have 4k and 5k. Everything else is going to be 0, so it doesn't matter. So all of these probabilities need to add up to 1. So k plus 2k plus 3k plus 4k plus 5k has to equal 1. So 15k equals 1. So to solve for k, we would divide by 15. So k is 1/15. So if we rewrite our table now, we have x, and p of x equals x. 1 is just k, so 1/15. 2 is 2k, so 2/15. 3 is 3k, which is 3 over 15, which simplifies to 1/5. 4 would be 4k, so 4 over 15. And 5 is 5k, so that simplifies to 1/3. So these are your probabilities. And now we want to find the probability that x is greater than 4. To be greater than 4, 4 is not included, so the only thing it's going to include is 1/3. So our probability that x is greater than 4 equals 1/3. So there's your answer to that. And then we said k equals 1/15. If it said the probability that x was greater than or equal to, then we would include this probability of 4 and we would add those together. Now we have our second IB practice question. It says below is the probability distribution for x. Part A says solve for A. So this needs to add up to 1. So if we add all of our probabilities together, we'll get that 1 equals 0.95 plus A. So if we subtract 0.95 from each side, we get that A equals 0.05. So that's our answer to part A, and we can fill that in over here. Next it says find the probability that x is less than 2. So for less than 2, 2 isn't included, so it'll be the probability of 0 plus the probability of 1, which is 0.04 plus 0.23, which equals 0.27. So this would equal 0.27. Part C says find the probability that x is greater than 3. So greater than 3 would be the probability of 4 plus the probability of 5. So that's going to be 0.05 plus 0.41, which is 0.46. Then finally, we have the probability that 2 is less than x is less than or equal to 4. So 2 is less than x, so 2 is not part of this probability distribution. You could have 3, and then since it could be equal to 4, you'll have the probability of 4. So we're just adding those together. So 0.18 plus 0.05 is 0.23. And that's it for this problem. So in summary, discrete random variables are variables that can only take on integers. Probability distributions can be written as a table or an equation. Your expected value is the value that's most likely to be the result of the trial, and that's the sum of each outcome multiplied by its probability. And finally, applications include gambling, business decisions, and return on investments, along with many other things. That's all for this video. Thank you for watching.